All right, welcome to 5.2, where we're going to look at adding and subtracting decimals. Here's what's really great about adding and subtracting decimals is it works virtually the same way addition and subtraction works with whole numbers, except that we are extending that idea out into more place values. And so let's have a look here. So the first thing we want to be mindful of is that we can always rewrite a number as itself and as many decimal points, as many zeros to the right of a decimal point as we need to express it in a way that helps us to add it or subtract it with other numbers. So for instance, if we want to combine these numbers up here, right? There's whole numbers, there's decimal numbers, there's numbers where there's a whole part and a decimal part, there's different place values. So one thing we can do, and this is not the only thing we can do by any means, but one thing we can do is we can standardize it and we can add zeros in all the places to the right that don't have decimal place values until every number has the same number of place values. So you can see 8 can be written as 8.00 right here, 0.000, excuse me. And 3.1 can be written as 3.100. Now those extra zeros, they don't change the value. You could just as easily write it without it. You could add 100 more zeros to the right and it still wouldn't change the value of that number because it's going to be 3.1 when you reduce it. And it's either going to be, whether something, and this kind of makes sense here. So if we look at this, this is the same as this, is the same as this, because 1/10 is the same as 10 hundredths. See how this is a 10, but it goes into the hundredths place now, which is the same as, this is 100, but it goes into the thousandths place value now. So 1/10 is the same as 10 hundredths, which is the same as 100 thousandths. So those are all the same, and that's why we can add as many zeros as we want to the right of the decimal in order to write the number in a way that helps us add. So in this case, we write them all with the same number of decimal places, and then we're able to line them up. And once you line up the decimal places, notice that not only are all the places lined up, but all the decimal points are lined up. Once those are all lined up, you can just add straight down, add and subtract straight down, like you would with whole numbers, as long as you keep that decimal point tracking where it is. That'll keep your place values organized. So let's go on and have a look at an example. Of course, the real world, is a little more difficult than addition often. So let's have a look at subtraction. So here, if we want to subtract 5.9 minus 3.0814, that's 9/10, and that's 814 10,000ths, then we have to line them up in such a way that their decimal points are lined up so that all the places are in the same place. All the place values are lined up. Now the challenge with that is there's nothing in some of these place values. So what I can do is I can add a 0 in order to have the same number of places so that I can see what I need to do. So I can see here, what I'm really looking at is something like 9,000 minus 814. So while I can't do 0 minus 4, I can't do that, I know that 814 will come away from 9,000. So I'm going to borrow from the 9, make it an 8, make this a 10, which of course I'll have to borrow, and then I'll borrow again. So I end up giving the 10 all the way down. 10 minus 4 is 6. 9 minus 1 is 8. 9 minus 8 is 1. 8 minus 0 is 8. Keep my decimal point lined up. 5 minus 3 is 2. And so that's how I can add and subtract decimals. And it's pretty straightforward if I've mastered standard integer addition and subtraction. I can move right along into decimals without any issue. So let's have a look at another one. What if I am adding two negatives? Well, if I'm adding any two negative numbers, then they're both going in the negative direction. So I'm going to add their absolute values and keep their negative sign because they're just making my, in this case, maybe my account more negative. Okay, so if my account's more negative, then I'll add the numbers and I'll keep the negative sign. So instead of thinking of this as subtraction, I'm really thinking of this as addition. So I'm going to line these up. And then when I line them up, because they have the same number of place values, if I'm mindful that they're both negatives, and so my result is going to be a negative, whatever I get, then I can add. So 5 and 5 is 10, carry the 1. 1 and 7 is 8, and 2 is 10, carry the 1. And 1 and 4 makes 5, and 2 is 7. And I have to make sure to bring my decimal point straight down. If I lined it up when I did my addition and subtraction, then I can bring it straight down. And so negative 7 would be my answer. All right, what about when the signs are different? Well, when the signs are different, we know that we're going to have to find the difference between the values. So we're actually going to subtract. And to subtract, we always subtract the absolute value, the smaller absolute value from the larger absolute value. And then that gives us the difference between the two numbers. So in this case, while I'm trying to take while I'm trying to take 6.89 away from 3.42, I can't actually do that math. The math that I can do, however, is 6.89 minus 3.42, and then I can know what is the correct sign. Well, the larger number was the negative number, right? The larger absolute value, the 6, and so my result is going to have a negative sign. So I know that already. I already know the sign of my answer before I've even calculated. Now I can go in and get a precise calculation. 9 minus 2 is 7. 8 minus 4 is 4. Carry my decimal point straight down. 6 minus 3 is 3. So 3.47, but it's negative. And I might have forgotten that if I hadn't decided what the sign of my answer was going to be before I made my calculation. Okay, so let's review some of the key concepts here. A, when adding and subtracting with decimals, why is it important to line up the decimal points? Because that lines up place value. And place value is all that the decimal point is indicating, right? It's simply indicating place value. So if place values are lined up, you can do your addition and subtraction. All right, B, write 379 and 6/10 in mixed number notation. So I think they want us to write it like this. 379 and 6/10. And of course, if I wanted to, I could reduce 379 and 6/10 reduces to, that's right, 3/5. So that's another mixed number version of that same decimal. And of course, this one is with tenths, and this one is in its reduced lowest form. All right, C. Why do we line up the decimals when we add or subtract vertically? Well, we line them up because it keeps our place values in line. That's right. So I'd like to copy and paste this right down here. So it keeps place value in line. How many quarters does the decimal 0.75 represent? How many quarters? So if you were to represent this, a couple of options here. You might know that this is 75 hundredths. You also might know that 75 cents can be written as 3 quarters. And if you reduce this fraction, if you divide, for instance, both by their common factor of 25, you'll find that indeed 75 hundredths does in fact reduce to 3/4, 3 quarters, and that's where the name, of course, comes from. So hopefully that made a good connection between decimals and fractions, and adding and subtracting them is just like adding and subtracting integers, except that you have to be mindful of place value a little bit more so by lining up the decimal and adding any what we call trailing zeros to the right of the decimal that you need to stay organized. All right, hopefully that answers some questions, and we'll see you in 5.3.